I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the interfacing of LED and 7-segment display with the 8051 microcontroller. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the 8051 programming in C. Let's see Introduction to 8051 Programming in C. The main concern in microcontroller programming is program memory space. Assembly language programming produces a hex file which is much smaller than that of produced by programming in C. That means for 8051 microcontroller we can write a program in assembly language as well as in C language. While programming with assembly language, the produced hex file have the smaller size than the .c file. But programming in C has some advantage. Let's see the advantages. The first advantage is that programming in C is less tedious and less time consuming as compared to the assembly language. It is easier to modify and update. The programming in C is portable to the other microcontrollers with little modifications, and the C also provides some library functions. Due to these advantages, the C language programming is preferred than the assembly language programming. Let's see some basic concepts about the C language programming. The first is bit addressable programming in C. A bit of any bit addressable SFR is defined as follows. That means P1.0 or P1.0 for port 1 bit 0, P0.6 for port 0 bit 6, PSW.7 for carry flag in PSW register, etc. That means by using this method we can write or we can address any single bit in C language. Okay. Now the next point is data types using programming for 8051 microcontroller. The following table gives the information about various data types used in C, their size and their range or their uses. The first data type is unsigned character. Its size is 8-bit and its range is 0 to 255. Okay, this is in decimal. In hexadecimal, this value is 00H to FFH. Here, the next data type is signed character. That means this character has the positive as well as negative value. Its size is 8 bits and its range is -128 to +127. The next data type is unsigned integer having the size 16 bits. Its range is 0 to 65,535. That is in hexadecimal it has the value 0000H to FFFFH. Now the next data type is signed integer. That means it has the negative and positive values. Its size is 16-bit and it ranges from -32,768 to +32,767. The next data type is S-bit. Its size is 1 bit and its use is bit addressable locations of SFR. The next data type is bit. Its size is 1 bit and its use is bit addressable locations of internal RAM. The next data type is SFR. We know that SFR means special function registers. Its size is 8 bits and its use is SFR locations of 8051, that is ATH to FFH. Okay, I hope you all got the basic idea about the data types using programming for 8051 microcontroller. Let's see some examples here. The first example or the first program is that write an embedded C program for 8051 to count 00H to FFH on port 2. That means we have to use the overall port 2, that means the total 8 pins of the port 2. Let's see the flowchart first. The first step is start, then the next step is A equal to 00H. That means 00H is loaded into the accumulator. This accumulator is now loaded into the port 2. Okay. Then increment accumulator is accumulator 0. Then go to stop is accumulator is not equal to 0. Then go to the step here. Okay. Let's see the program here. Hash include register 51.h. Here register 51.h is the header file used for 8051 microcontroller. Void main opening brackets unsigned character A for A equal to 0, A less than or equal to 255, A plus plus, P2 equal to A, that means assign variable to port 2 pins, closing brackets. This is the program for to count 00H to FFH on port 2. Okay. Now the next program is that write an 8051C program to toggle bit 0 of port 1 10,000 times. First of all, we have to know that what is meant by toggle. The toggle means to make the complement. That means if the bit has the value 1, then make it 0. If the bit has the value 0, then make it 1. Continuing this process, that means 1, now make it 0, 0, now make it 1. This process of complementing continuously is known as toggling of bit. Okay. Let's see the program. Hash include register 51.h. Here s bit, my bit is equal to p1.0. That means here p1.0 is assigned as the my bit. Okay, that means it renamed as my bit. Void main void unsigned integer I for I equal to 0, I less than or equal to 10,000, I plus plus. Okay, now in a loop we can write my bit equal to 0, that means p1 0 is equal to 0, and then my bit equal to 1, that means p1 dot 0 equal to 1. Here we make it 0 to 1, that means we toggle it. Hence it is the program for toggling bit of the port pin p1.0. I hope you all understand the C program. Now the next point is time delays in C. The time delays can be created by two methods in C language. They are using a simple for loop and using 8051 timers. While creating time delay using a simple for loop, we cannot get exact time delays. Okay, if we use a for loop to generate a specific time delay, then it may be possible that the generated time delay is not accurate. To get the accurate time delay, we have to use 8051 timers. Okay, now let's see the example on it or the program on it. Write an embedded C program for 8051 to toggle the bits of P1 continuously or to generate a square wave on all pins of port 1. We have seen previously toggling means if it has the value 1, then make it 0. If it has the value 0, then make it 1. That means If we draw a wave of it, if the value is at 1, then make it 0, then again make it 1, make it 0, 1, 0, 1. This creates a square wave. Hence, the toggling program means to generate a square wave. I hope you all understand the concept. Let's see the flowchart first. Start, then P1 equal to 00H. After start, assign P1 00H means the value 00000000. Now give some delay, and after the delay, now make it P1 equal to FFH. That means P1 equal to, we have to toggle it. That means we have to convert all the zeros into ones. 1 1 1 1 1 1 1 1. That means F F H. I hope you all understand the concept. Let's see the program. Hash include register 51.h. Let's see once again. The register 51.h is the header file used in 8051 programming in C. Void main void integer x while 1, that means continues repeatedly P1 equal to 0 cross 0 0. That means assign value 0 0 to port P1. This is the software delay for x equal to 0, x less than 500, 5000, x plus plus. Then P1 equal to 0 cross FF. That means now load FF value into P1 for x equal to 0, x less than or equal to 5000, x plus plus, software delay. That means this loop continues its execution and we get the toggling of the port 1 bits. Okay, while 1, that means repeat forever. This loop gives us a square wave or a toggling of the port 1 bits. I hope you all understand the program. Let's see one another program here. Write an 8051C program to toggle bits of P1 ports continuously with 250 milliseconds. Its solution is hash include register 51.h void ms delay unsigned integer void main void opening brackets while 1, that means repeat forever. Here P1 is equal to 0 cross 5 5. That means now P1 is assigned the value 5 5. That means 0 1 0 1 0 1 0 1. Okay. Then ms delay 250. Here the delay of 250 millisecond is given. Then make it P1 equal to AA. AA means 1 0 1 0. This is A. Again 1 0 1 0. That means making this 0 to 1, this 1 to 0, this 0 to 1, this 1 to 0, 0 to 1, 1 to 0. That means toggling of the bits. Okay. Hence, first we give the value 55 and then we give the value AA. This combination gives us the toggling of all the bits. Now here is the delay subroutine void ms delay unsigned integer I times. Unsigned integer I comma j for I equal to 0, I less than I time I plus plus, for j equal to 0, j less than 1275 j plus plus. The next type is input output programming in C. Its first type is byte size input output programming. The ports P1, P0, P2, P3 are byte addressable. We use the labels P0 to P3 defined in the 8051 header file. Okay. Let's see the program on it. LEDs are connected to the bits P1 and P2. Write an 8051C program that shows count from 0 2 FFH on the LEDs. Okay, that means the 805 with the 8051 microcontroller, the LEDs are connected to the port P1 and the port P2. Okay, then we have to show count from 0 to FFH on the LEDs. We have to show the count of 0 to FFH on the LEDs. The program is that hash include register 51.h. The next line is hash define LED P2. Okay, that means the P2 port is now labeled as LED, or the P2 port is renamed as the LED. Okay, void main void opening braces P1 equal to 0 0. That means P1 assign the value P1 equal to 0 0. That means clear P1. LED equal to 0. LED means P2. That means clear P2. For, that means repeat forever. In opening braces P1 equal P1 plus plus, that means increment P1. LED plus plus, that means increment P2. Closing braces. Okay, I hope you all understand the programs. These programs are very simple. Okay, now the next program is write an 8051C program to toggle all the bits of P1 continuously. The solution is that hash include register 51.h. We have to write this line when we programming with 8051 microcontroller. Void main void opening braces for, that means repeat forever. In for loop P1 equal to 0 cross 55, that means 55 value is loaded into port 1. 55 means 0101 5 0101. Then next instruction is P1 equal to 0 cross AA, that means 1010 1010. Each bit of P1 is toggled, that means 0 complemented to 1, 1 complemented to 0, or 0 toggles to 1, 1 toggles to 0, this 0 toggles to 1, this 1 toggles to 0, this 0 toggles to 1, or this 1 toggles to 0. We can give this value as P1 as 00H, that means 0 cross 00H, and 0 cross FFH. Okay, it is depend upon our choice. The next type is input output programming in C, bit addressable input output programming. We know that the ports are byte as well as the bit addressable ports. That means the ports P1, P0, P2, P3 are bit addressable. We can access a single bit without disturbing the other port bits. We use the 8-bit type to access a single bit of P0 to P3. Let's see the example. Write an embedded C program for 8051 to continuously toggle port 1 pin 4, or generate a square wave on port 1 pin 4. That means we have to toggle only the pin number 4 of port 1. Okay, let's see the flowchart. First start, then make P1.4 is equal to 0, then give some delay. After some delay, make P1.4 equal to 1, then again give some delay and return to the start. Okay, the program is hash include register 51.h. S bit my bit is equal to P1.4, that means port 1 pin 4 is now named as my bit. Unsigned character X, void main void, opening braces, while 1, that means repeat forever. This loop now repeats forever. My bit equal to 0. Here my bit means P1.4 is equal to 0. For x equal to 0, x less than or equal to 5000, x plus plus. This instruction gives the software delay. Then make my bit equal to 1, that means first it has the value 0, then make it 1, it gives the toggling process, then it has the value 1, toggle it again, that means make it 0. This process is known as the toggling of the bit. In this process we get a square wave. Okay, this line gives us time delay, closing braces. Okay, I hope you all understand the programs here. Let's see the next program. Write a program to switch on the alarm connected on P1.7 when the lift door is open. The door opening is sensed by the sensor on P1.1. That means here a lift is shown, and if the lift door is open, then the alarm is connected with the P1.7 pin and it should be alarm. Okay, let's see the flowchart first. Start. Program the P1.1. P1.1 means the door opening sensor is as an input pin. Okay, read the status of P1.1, that means read or check whether the door is open or closed. Is P1.1 is 1, that means is the door is open, then make the alarm on, that means make P1.7 is equal to 1. Okay, if the door is not open, then again go to this instruction to read the status of the door, that means whether it is open or closed. Okay, then after making P1.7 1, that means after making alarm on, then give some delay, and after delay make the alarm off, that is P1.7 is equal to 0. Let's see the program. Hash include register 51.h. Here s bit door equal to P1.1, that means this door is now assigned as, or P1.1 is now assigned as the door. P1.7 is assigned as the alarm. Void main void opening braces integer x door is equal to 1. That means programming the programming the pin P1.1 as an input pin. While 1 opening braces, if door is equal to 1, that means checking P1 pin, then alarm is 1. If the door is 1, that means door is open, then alarm is 1, that means P1.7 pin is now 1 and the alarm is ringing. This instruction gives us this delay, and after this delay make the alarm off. For that purpose, right here alarm is equal to 0 and give the closing braces. Okay, this is the program. The next type is assessing SFR address ATH to FFH. We can assess the SFR RAM space ATH to FFH by using SFR data types. We can also assess a single bit of any SFR if we specify the bit address. The programmer has to know the corresponding addresses. There is no need to put hash include register 51.h file in the program. That means when we assess SFR addresses ATH to FFH, then we don't need to write this line hash include register 51.h. Let's see the example here. Write an 8051C program to toggle all the pins of port 0, 1, 2, 3 continuously with software delay. Use the SFR keyword. Here we have to use SFR keyword, hence here hash include register 51.h line is not written. Directly written here SFR P0 equal to 0 cross 80, that means declaring P0 using SFR data type. SFR P1 equal to 0 cross 90, SFR P2 equal to 0 cross 80, SFR P3 is equal to 0 cross B0. Unsigned character I, void main void, while 1, that means repeat forever. Now P0 equal to 0 cross 0 0, P1 equal to 0 cross 0 0, P2 equal to 0 cross 0 0, and P3 equal to 0 cross 0 0. That means all the ports have the values 0 0. Okay. Then after some time delay, make it P0 equal to 0 cross FF, P1 equal to 0 cross FF, P2 equal to 0 cross FF, and P3 equal to 0 cross FF. That means after this delay, make all the values of ports as FF. That means 0 0 to FF means toggling of all the pins of the ports. Okay. Now let's see the next type, logical operations in 8051C. The different logical operators used in CR, and for byte addressing we write this symbol for the AND operation, or for byte addressing we use this symbol for OR operation, and for byte addressing we use this symbol for the NOT operation. The programmers are less familiar with bitwise operators. That means for bitwise operation we have to use AND means this symbol, OR means this symbol, XOR means this symbol, inverter means this symbol, shift right and shift left. Let's see one example here. Write an 8051C program to get the status of port P2.7 pin, toggle it and send it to P2.0 continuously. Its program is hash include register 51.h s bit in equal to P2.7, that means P2.7. This pin is assigned as the input pin, and P2.0 is assigned as the output pin. Okay, void main void, opening braces, while one means repeat forever. Here out is equal to complement of in, that means not in. Okay, out means P2.0 is equal to not P2.7. That means toggle status of port 2 port pin P2.7 is transferred to pin P2.0. Okay, I hope you all understand these simple programs. Now the next type is data serialization. It is a method by which the data can be received or transmitted bit by bit using a single pin of microcontroller. There are two methods to implement this: serial port and serialization. In serialization, we use shift instructions and transfer the bits one by one. Data serialization means data transmission process. Okay, we can conduct this transmission process by using serial port or by using the serialization method. Let's see the example or the program on it. Write a C program to send out the value 88H serially at a time via P3.0. The MSB should go first. Its program is hash include register 51.h s bit out P3.0. That means P3.0 pin is now assigned as or renamed as the out s bit serial accumulator.7 pin, void main void, opening braces, unsigned character data 0 cross 88, unsigned character I for I equal to 0, I less than 8, I plus plus, opening braces, ACC is equal to data, out equal to serial, ACC equal to ACC less than 1, that means send out 88H serially, while 1, that means repeat continuously. This is the very simple program here for transmission of the data. Okay, I hope you all understand all the programs related with the 8051C language. Thank you.